I am so pleased to introduce Dr. Mark Liu and actually ask him to really talk about his background more so than me offering a story or kind of a set of tidbits. Because part of what for me is so exciting is his pathway is not standard. He's been a fashion designer, he's a mathematician, and he has really synergistically melded these backgrounds and skills together. And in that, I think it's offered us some really exciting solutions that we're seeing used across the fashion related industries. So Mark, please, I'm so happy that you could join us and share what you're working on now and also a bit more about your background and story.
Hi, it's wonderful to be here virtually. I think if I'm going to sort of take it back to the very beginning of where a lot of it started is usually I'm actually from Australia. And when I first started as a fashion designer, we had these buildings. There was the design building, and on the other side, you had the science building. And it was the final year of my undergraduate degree, and most people were writing they had to write a thesis about a particular topic. You could write about corsetry or feminism. I made this decision to write about the implications of nanotechnology fabrics on textiles. And this was over sort of 20 years ago. So at the time, this was quite a novel thing. But I would actually cross that bridge from the design faculty over to the science faculty and make that physical journey and talk to a whole bunch of different people. And I think that's really where the journey started. It was crossing that bridge physically, but also it was almost a metaphorical journey to go to a different place where people almost spoke a different language, they had different values, but at the same time we had this common curiosity about how things worked. And that eventually took me to the UK. I ended up studying a master's in textile futures at Central St Martin's College, which I think the course is now called Materials Futures. And that was a wonderful course. Central St Martin's, of course, it's almost like the Hogwarts of fashion schools in the UK. But it really got me on this journey about high technology and sustainability. And science is what kind of tied them all together for me. As a student, I was very interested in all the high-tech materials. I got there looking for nanotechnology, and very quickly I realized that it was a little bit too early for that kind of nanotechnology. It was stuck in a lab, and I needed something tangible. And there was the growing existential problem of sustainability in the fashion industry. There was a big problem with wastage. And at that moment in time, this was around 2006, the awareness of sustainable materials, even things like organic cotton, there was nowhere near the mass market appeal of it. It was quite an obscure thing that only a few people knew about. We also had a problem that the aesthetics of sustainable designers was a complete nightmare. People thought of just like gray or beige dresses, and no one really, it was in a bit of a slump. And it took a while for designers, like really high-end designers, to start looking at sustainable materials and start bringing aesthetics, but also integrity to their sustainable designs and thoughtfulness to the scientific rigor of how they could make things more sustainable to this process. So it was a combination of aesthetics, science, and like you can't throw away everything. If you want fashion, you still need stories, you need themes, things still need to be sexy. And that was the thing. You couldn't just be a beige dress. You needed to tell a compelling story and do some cutting edge research. And I loved that. And I was in the right place at the right time at the intersection. And I was enthralled by the idea. I found an obscure area that was almost abandoned by the industry. And that was the idea of zero waste design in clothing. And I looked at the research and I found in the textile process that people were saving 1 or 2% of the material on a roll of fabric. That was seen as a massive saving. But if you look at how we make clothing as designers, at the pattern making process where we lay out all our patterns on a flat piece of material, we're wasting about 15% of the material. And I was shocked, and I thought, this is a real opportunity for designers to make a difference. it's difficult for a designer to go into the lab sometimes and invent a new material from scratch, but cutting fabric in different ways, redesigning things, using your creativity, that's a lot easier to do. Well, that's what I thought at the time. And so I went in, I started to redesign these garments, and it was a real challenge. There was a reason why people didn't zero waste design. It was really, really hard to make it. You could get really close. You could reach like 10% wastage or 5% wastage, but to do 0%, you almost needed to rethink how everything worked from scratch. And that eventually brought me down another pathway. I was finding that I wanted to be the ultimate tailor. I needed to know how everything worked, and I studied tailoring obsessively. And for me, it never actually quite worked the way it's supposed to. You always measured everything, and then you drafted everything as a flat pattern, but it never quite fit exactly the way that I wanted it. You always had to refit garments, and this was just seen as business as usual. This is how the way things were done. And when I was doing zero waste, it was like I studied so many different techniques that different designers used, but none of them actually gave me the accuracy that I was looking for. And I was frustrated. I wanted more. And there was this is a strange tangent, but at the time, if you wanted to watch television in the UK, you actually needed to have a license. And I think this is before the time where you just had streaming Netflix. So this was a time where DVDs still came in sleeves that they mailed to you. You needed a license for your TV. And I just didn't have, I didn't want to pay for a TV license. So I would go to the local library, and all the books in the library were my entertainment. So instead of watching TV for several years, I would just borrow a bunch of books. And each book was like a TV channel. So sometimes I would need something really fun, so I'd have like a nice design book. But then on the other side, I would get a mathematics book. And making that journey, like crossing that bridge again to the mathematics side of things, I realized that mathematicians had solved a lot of the curved geometry problems that we were struggling with as designers. And there was a field called Non-Euclidean Geometry, the geometry of curved 3D surfaces. And curved 3D surfaces have completely different geometric rules to flat surfaces. So you're probably used to the geometry of like Pythagoras theorem. Like people find it quite boring, but you have all those triangles and things that you learn in school. If you study mathematics in university further on, you find that if you're on a curved surface, they're completely different geometric rules. So imagine if you're flying around the planet on a plane, you're not actually taking a linear journey, you're curving around the Earth's surface, and you need to adjust your coordinates for that. Like if you were doing the calculations, if you were traveling on a boat, you're also going around the curvature of the surface of the Earth. So you can't just use linear math on a curved surface. And I very quickly realized that this was a massive problem in fashion, because we were taking these linear measurements, we were putting them to curved geometry, and it wasn't working. And this is where a lot of the errors were coming in. So with this knowledge in mind, I was able to completely break a lot of the rules that we were using in tailoring. People were following these traditional pathways, and I just went and followed the structure and function of the geometry of how things work, the geometry of the universe. And it became this universal language, because I went to several tailors and they all told me, this is how you do one technique, or this is the only way you do the other technique. But mathematics was universal, and it was this great unifier. And I still think it is a great unifier for most disciplines. So it allowed me to really interrogate the entire process from the ground up and reevaluate everything as we went along. So you could challenge the assumptions that came before you and then go ahead and rebuild the system the way that you wanted. So as a fashion designer, I was similar to a lot of the students. I was a master student. I created a collection of garments, and they were zero waste. They were from a textile school, so there was a lot of frilly textiles put together. The patterns fit together like a jigsaw puzzle. I was very much influenced by people like MC Escher, who could get patterns to fit together, but the patterns had these beautiful themes and a sense of humor, and that's what made them really beautiful. And I was approached by, I call her the fairy godmother of sustainable fashion, this wonderful lady, Ursula de Castro. And at the time, they had just started Aesthetica, which was the world's first environmentally eco-ethical fashion week at London Fashion Week. So it was ethical and sustainable fashion designers showing at Fashion Week in the same tents and venues as regular Fashion Week. And at the time, that was revolutionary. You would never have seen sustainable fashion designers going off and being in the same tent as the big designers. And we were unknown. Like, our research was known in small circles, but we weren't big brands at the time. People like Alexander McQueen loomed over everyone, and like Vivienne Westwood. You had these big brands, and it's like, oh, we're showing in the same tents as them. This is amazing, coming out as a student. So you were able to get your collection out there very quickly. And for me, I really love my process a lot of the time for zero waste is sometimes you're not guaranteed that your garments are going to fit together and create zero waste. So you have to make lots and lots of attempts, and many of them are going to fail. So I just kept on making and making and making. And over the time, this iterative process, I got better at doing it, and I could speed up the process because I was the designer, the pattern maker, and the maker all at the same time. So I was able to work very cleanly. I was able to move at the speed of thought because I was talking to the pattern maker. I was the pattern maker and I was the maker. So on a very small budget and a tiny material budget, because everything was zero waste, I was able to put the collection together. And this is one of the ways as students, you have to keep things lean. Let's be honest. We don't all have millions of dollars to throw around. So you were able to get your ideas out there really quickly and with the absolute control and precision that you really wanted. And I was able to show these ideas. And at the beginning, people said, oh, so the showcase garment, that one is zero waste, isn't it? And I said, no, everything is zero waste. And they weren't quite ready for that. They thought, so they're like, just this one or this one? I was like, no, everything. And they're like, that's a lot of effort. And I'm like, yes, it is a lot of effort. So they weren't quite expecting me to have done it to that extent. But then there were other questions that I didn't answer myself. So how do we scale clothing into different sizes when it's zero waste? How do we, like if we're going to do vast numbers of these things, a lot of them I cut by hand, and I could laser cut them. But at the time as a student, you're like, I could laser cut them, but I could cut them by hand and save some money. And it is that ridiculous sometimes. It's just a labor of love. And they're like, how did you cut that fine detail? I'm like, tiny little scissors. And people did not expect that. And I guess it's a little bit masochistic, but you realize you will have to relinquish a little bit of control. You will have to laser cut something after a while. And this took me through this process. It's like, you can come up with all these concepts, but it is a very different game to run a long-term fashion label, which can be reliable. And you will need to delegate, which I was used to doing everything myself and having absolute control. And this is also where fashion becomes, it is a multidisciplinary skill set. There is business acumen. You will need to raise capital. You'll need a place to do things. At the time, I was very lucky. I was able to win artist bursaries and fellowships. So and this was also post-global financial crisis. So the mad money that had fueled fashion and the patrons of the arts when I first came out, absolutely gone because they'd all been wiped out. Government funding was at all-time low. I was an Australian in the UK, so I wasn't really eligible for most of the funding that most people had. So I was just like on my own. The agencies such as the London Print Work Trust, who were able to support me, did an amazing job. And I was there and I was able to do printing with them. They gave me a studio. I was able to, I sparked up all sorts of synergistic relationships with other designers. So I would do their pattern making and they would lend me their studio in the night to do making. So this is how you survive in the big, you barter, you hustle. That never goes away. Or maybe when you have a giant label with great corporate governance. But at the very beginning, as students becoming young label designers, You do what you do to survive using your skills. Your skills are valuable. Your ability to pattern make, your ability to draw, illustrate, the ability to create textiles and beautiful images, or even write beautiful things. They are valid skills, and you should use them because, yeah, society places value on them. So I was running this kind of little label, and I was finding that it was quite difficult to sell because I was selling almost like couture things, and it was quite a small market. And I did want to take the route and print t-shirts and things like that, and I did a few of those, but I was getting really entranced by the research itself. And the more I looked at the geometry of fashion, the more I looked at the industry, I almost thought, this industry needs to change, but I can't beat it now. I almost need to beat it in like 10 years' time. And I thought, well, I can't wait this long. What am I possibly going to do? I need almost like several lifetimes of experience, but I need it now or in 5 years when the industry has progressed, because it's almost like it was too soon for certain things in the industry. People wanted organic t-shirts. They weren't ready for zero waste couture. They weren't ready to retool their entire factory just to save materials. So I ended up having this deep thought, and I needed to almost just go off and do my own thing for a while. So I was running the label almost as an artist, and I would go to museums and they would commission me to make a collection, and I could make the collection, and I could then get paid by the museum, show the collection, and then keep the collection. If you're a fashion designer, you're the first person to pay money and you're the last person to get paid. And it's actually a very difficult business unless you make something much more commercial, much more fast fashion-y. I was doing everything by the book. It was all local manufacture. It was zero waste. It was either materials that were reclaimed from waste. So it was difficult to run the 100% ethical label that I wanted, but it was possible to run it as an artist. And I was like, I need to go deep and figure this stuff out. So I actually went back, and I went back to Australia in the middle of, went back to my the place where I originally came from, and I wanted just to be really obscure for a long time. And I did a PhD, which is a really weird thing to do, but I needed to solve that thing about curved geometry. So I went back and I actually wrote an entire pattern making system from scratch based on curved geometry. So it's easy to complain about a system. It's really difficult to build one from scratch. So I took the mathematics of the mathematicians, which was really quite complex and inaccessible to most designers, and I had to pare it down into a way that was easy enough for a fashion designer to understand. And even when I first started showing it, there was just a general apathy by design, like the design school, for this stuff. A lot of people said, it's too complex, the math, no one's ever going to really get it. So I decided to go and teach it to a bunch of children. And I made a bunch of paper dolls, and I made a bunch of paper models, and I got them to cut them out. And we were able to teach these principles by, I think it's embodied learning or kinesthetic learning or tactile learning. So it was visual. You got to play with things instead of equations on a board. And there was a real moment. I think there was a festival in Australia. It was a festival of ideas, and it was at our university, and I was presenting to a bunch of people at the time. And right next door to us, I think in the theatre, there's the Australian it's the Australian video developer called Animal Logic. They did special effects for The Matrix and the Lego movie. Beautiful special effects. Whatever Animal Logic are doing, it's going to be far more interesting than what I'm doing. So, like, if you get to see the preview of a cool new movie, I would go to that instead of seeing mathematics and fashion at the same time. So I went there and I presented some of my things, and there was 7 people in the audience, and I showed them how to find an integral using fashion design. I showed them how to differential calculus work by cutting some things out, and I got applause by 7 people. But then afterwards, the cameraman came up to me. He's like, "That is the first time I've actually understand what any of that calculus stuff meant in school." And it's been this long. I was like, thank you, cameraman. But because there were like 7 people in the audience, I think there was a thing where they would score who had the highest rating of, like, there was a feedback rating of who you thought was really great. And because there were 7 people and they really enjoyed it, my stats were through the roof because 7 people gave me like really high scores. And for some reason, this tiny little presentation I did put me on the radar somehow. And there was a person from Samsung there, and they really loved it. And they made me a STEM ambassador for Samsung. So I was able to go out there and take some of these principles and engage young people and teach them about all the different things that they could, the intersection between fashion and STEM education. So after doing the PhD, which was a very intense process, I won this thing called a Chancellor's Postdoc Fellowship, which is, it's a prestigious post where for 4 years you get to do research. And I really loved that opportunity. And the crazy thing is, like, your research competes against all disciplines. So it's like cancer research competing against quantum computers. And I was doing fashion, STEM, and 3D algorithms and things like that. So it was a real surprise to actually win it. But once I got in there, I was like, I'm going to take full advantage of all of these things. So I went out and I crossed all the bridges. I started talking to the law faculty. So I've recently, we have a paper that will be coming out next year about how gender justice is intrinsically tied into sustainable fashion, and how the UN's Sustainable Development Goals, which we measure everything against, those SDGs, we argue that they are actually gender biased. So even if you achieved what they were hoping to get, there are gender biases in things like what people do in their grey labor and things like that, that do actually make things harder for women than for men in the process. So go to the legal faculty and pursue fast fashion policies and things like that in collaboration. I went to the science faculty and I started working with them on algal fabrics. So algae is absolutely amazing. It sucks up carbon dioxide and outputs oxygen while creating, you can create carbon dioxide. I mean, you can create things like carbohydrates, fats and lipids. You could theoretically build
a little
anything.
bit more about this type of fabric. I think that there are going to be people here who don't really know what algae is. So maybe you can give them a quick understanding of that here, so they can really appreciate its value.
Algae often gets a bad name because people think of blue-green algae and algal blooms, but that's actually cyanobacteria. That's a different thing. Algae, in the tree of life with animals and plants and fungus and everything like that, algae is actually larger than all of them. It's a primary organism. So algae can be as simple as a single, it can be a microalgae, which is almost invisible to the human eye, which may seem like green water that's growing in a lake or in a pond, or it can be things like macroalgae. So that can be seaweed. So you can kelp, things that the seaweed that you eat, that can be a form of algae. They're diatoms, which are really tiny little organisms. And there is an entire plethora of organisms in between seaweed, all the way down to a tiny little microorganism that is a couple of cells. So algae are these original organisms that created the Earth's the oxygen in our atmosphere. So 50% of the oxygen in our atmosphere is actually created by algae itself. And even things like fossil fuels, they're kind of like dead organisms over time, but they are almost like algae from a completely different generation. So on planet Earth, we actually owe a lot of what we do to algae itself. And it's one of these biological organisms that have been massively overlooked. People looking to genetically engineer all sorts of things to save the planet, but there are all sorts of organisms that are already doing a great job of it. And there's a group called the Climate Change Cluster, and there's also another group called the Deep Green Biotech Hub in Australia. And we just happen, by chance, to have the highest concentration of algal bioscientists on the planet. A lot of them are some marine biologists, but they are obsessed with algae, and their goal is to basically wean us off a fossil fuel-based economy and make everything, absolutely everything, from energy to materials, everything from what we eat to the plastics that we make to the fertilizer that we use. They want to make everything from algae and build this brand new algal bioeconomy. So in the context of that, fashion is, it creates 8% of global carbon dioxide emissions by some calculations. So algae as a candidate to replace things like cellulose or replace the fossil fuels that make plastic are a very desirable area of research. This is an area that I've been really keen on. So when I first came over to the science faculty, I engaged them in a discussion, and it was really quick. We basically looked at the impact of things like polyester and cellulose-based fabrics, and immediately they could see the potential of that. And we began a journey to almost bioprospect, go out into nature and find the organisms that would best make a algal fabric, say made out of cellulose, or an organism that could make a polyester-based fabric from algae. Does that help? Yeah.
No, I think that understanding of, how algae works, how we can use it as a new material base in there, I think that's something that's really interesting when we think in the space of like biodesign and biomimicry and design that's based off inspiration from nature, and understanding that there's a lot of factories in nature that give us a lot of information about how the importance of things like weave patterns or what materials exist. So I think that's a really exciting space in this journey. And of course, I love all of the crossing of bridges that you've been discussing, because I think the different voices have given to kind of how we're thinking about moving forward in the space of sustainability today.
I think in Australia we have particular laws. So I've actually been to places in Brooklyn where they have really amazing, they're almost like a makerspace, but it's for synthetic biology. And in Australia, unfortunately, our laws are much tighter because of our, we have a very delicate biosphere in our area. So a lot of the things that you can just do in a lab there and you take for granted, we have to do in a contained lab, and we can't take our organisms out of the lab in the same way. So we had to be much more careful. And because I think our labs are so careful about not letting things out, we needed a lot more expertise in that area. So the people that we were accessing, they tended to be very advanced sort of postdoctoral scientists. But what was really great was when we could actually engage these postdoctoral scientists with young designers who had all sorts of ideas, because they can make your material, but the question is like, why would you make that material? We needed that infusion of new ideas and that enthusiasm and almost like an entrepreneurial spirit as well to see how you could overturn an existing system using new algal-based materials.
That's really interesting. So how is, in this space, all of it now working on what you're actually working on?
How
is, when we think about this, did this early work and crossing over during your postdoctoral time kind of inform what things are really inspiring or infusing your work today?
I think what is important is science is this great communicator. So you can learn the underlying, in say fashion school, you learn some of the underlying material science of materials such as fabrics. When you cross over to the science faculty, you can speak this language to other scientists, and you do have to speak in their particular language, but it also allows you to read new papers. It allows you to stay up to date with new trends in their community. So you're no longer just a fashion designer. You're more than that. You're almost you're a connector of people. You're a person who brings things together. I also often equate it to, it's almost like you need to create something. It's like the Marvel movies. It's like you almost have to put the Avengers together and get them all to do their task. And there'll be one scientist who is really good at one thing, and there'll be an engineer who can build you another thing. And it's almost like these relationships that you build and bring them together. You can pull things together that you really couldn't do normally, because you can speak in a different language, which has this ability to cross boundaries, but there's also a certain trust, and there's ability to see why you would possibly do things, because if you're not speaking the same language, it's very easy to dismiss these ideas. Like sometimes a new idea, it's quite fragile and it's easy to crush. And I find being able to speak the language of science, it translates to engineers, but also the ability to make really cogent, like very defined definitions is very useful as well if you head to, say, the business faculty and the law faculty. One of the difficulties I had when publishing things like papers, I recently had to publish some papers for a legal faculty, is that a lot of the statistics that we use in the fashion industry, they're kind of vague, and they aren't really that well. If you were to bring them to a scientific journal, they wouldn't actually pass peer review process because their sources are not particularly good. And it's almost like we need more rigor. Like design, fashion design almost needs to grow up just like the other disciplines do. And we grow up by sharing with them. So I was looking at the definition of something like circular economy, and it's such a pervasive word, or sustainable design. And there was one paper by a group, I think it was Kutcher et al. In 2017, and they had looked at, there were over 114 definitions of circular economy. So imagine you're trying to use one word and there's 114 definitions of it. No one can agree on what that actually means. It makes it impossible to do anything. So from a legal point of view, if you had a contract and there were 114 definitions of what you had to do at a certain point of time, or in a business deal, there were 114 definitions, you couldn't actually get any contracts to work because they're just unreasonable. Science is great because you can agree on universal definitions or have different definitions that you can use, and they make them workable. We have a problem with sort of greenwashing and wokewashing, where if you can define anything to mean anything, you can get away with anything at the same time. So it was really important to get these definitions down so that you could work with everyone and get them to agree to things on a much deeper level, and then dig deep into that sort of deep technology. So you could be making real breakthroughs instead of just rebranding things or superficially looking like you were doing something.
I think that's really an interesting perspective on how we're talking and considering how these intersectional points. I think the intersectional points in communication is really key, and helping and providing pathways when we think as educators about the importance of creating good, clear communication, but also communication that can bridge gaps and cross disciplines without it being, for lack of a better word, a hard bridge to cross. I chuckled when you talked about, your calculus explanation, but the reality is, oh dear, I'm so happy I passed calculus and I haven't really thought a lot about it since then. But, when mathematics works and helps us solve problems, it's fascinating, and it allows us to look at data in different perspectives and ways. So I think that is really, really interesting. Now, I know you've been working on some newer work that really goes towards solving, especially some of our immediate challenges related to the pandemic. And so I wanted to make sure to give you a little bit of time to talk about that. And then I'm going to want to come back and talk a little bit more about this transition from 2 dimensions to 3 and back and forth again, because I think there's a lot of really interesting components in that space. So maybe I'll talk just a little bit about your work that you're doing today, where you're working at all different levels in some cases, I believe, within the supply chain on this process.
Yes, so when working on zero waste, I was working in a very high-end designer capacity, and you were making one or two garments. A lot of them would go to museums, and they were lovely, and they would sit there and be exemplars of, you know, what creative things that you could do. But they were only a small handful of garments. I like a challenge, and one of the biggest challenges that we have is single waste personal protective equipment. Especially with the pandemic, it has become such a valuable asset. But as a challenge for a designer, single waste plastic materials in medical waste is such a challenge. It is a challenge not just on a scientific level, it is also on a legal level. In Australia, we have certain laws where we can't even dispose of our own waste. I don't think we can even incinerate certain parts of our waste if it's contaminated medical waste. So what we would do is we would take all our contaminated medical waste, and I think we would actually ship it to a different country, and they would have a facility that is rated to do that. If you think about, you know, what we're doing on a scientific level, we're taking all our diseased and contaminated material and we're shipping it on boats around the world. That is not a great idea in a world like post with global pandemics and things like that, and antibiotic resistance on the rise. So I started working for a medical company called Multigate recently, which is one of Australia's largest personal protective equipment suppliers. And they had an extremely ambitious goal. They wanted to create the next generation of medical gown. When we were working with the medical gowns, the gowns were laid out in a way that was about 90% efficient, which is pretty decent, but still it created a lot of wastage. And when you created the wastage, the factory also would charge the manufacturer for everything that you had to dispose of or recycle. So it wasn't actually a good thing to create waste. It actually cost you a bunch of money. When I came to look at the patterns, it was a very traditional process. No one had really changed the way that gowns were made in such a long time. And I tried some really radical things. I tried sort of squishing everything together using a sort of zero waste technique. And it was sort of getting the tops of the garments to fit together really nicely. And it's just simple things like that. Being able to save a little bit of material, so 2 or 3 centimeters of material on the top here and there. It doesn't sound like a lot, but that translated to a massive saving down the road in terms of the amount of material wastage. We started getting really clever with it, and I created something that was zero waste. It had a V-neck and it was very nice, but at the same time, there are certain things that were accepted by the medical industry. So they wanted things that were comfortable, things that looked familiar. So if I was in the university, I would say, this is the ultimate zero waste pattern. It is a V-neck. It fits together like a jigsaw perfectly. This is how we can do things. But for doctors and nurses, if you take it to them, the great thing about being a medical company is they came in and surgeons would look at it. Nurses who had to put these things on every single day. The entire design team would critique and scrutinize everything. So we took the zero waste gown and we would have to modify it. We'd have to modify the neck so it was easier to wear. It was more comfortable. So reality came in. There were compromises that had to be made. The great thing is we could make compromises, but then we would find other ways of being more efficient. So even the notion of zero waste became quite tricky because we managed to reduce the meterage of the fabric, but then we were able to use different parts of the fabric for different things. So on many of the medical gowns, they have these, these thin lines, they're ties. So you tie the medical gown just like you would an apron around the back. So we were making areas that were rectangular, and we could cut these ties into, we could cut the wastage into ties. So suddenly we didn't have to pay for extra ties. We could just use the area embedded around the material for ties. And it was this really intricate process where it was a balancing act between absolute sort of efficiency on one side and what was performance. And when it comes to medical wear, you can't compromise on performance because the industry will not accept it. There'll be a backlash from all the people who, like, this is every day, all the people in the medical industry have to suit up and they want to feel protected and comfortable. And you can't take that away from them. You want to make their lives better and more comfortable. So we try to address a lot of their issues. We failed doing a whole bunch of different things as well. So we tried pleating medical gowns, which is still, I still love the idea of it. So I was like, can everything look like Isimiaki's pleat, please? Like pleats, please? That would be amazing. But materials have certain limitations of what you can do with them. But working with that process was really amazing because you found little niches. And one of them was a difference between the Australian market and I guess the UK market. In the United Kingdom, they are very much like in Australia and in the States. We wear medical gowns in certain times and places in surgery, but there are certain places where you don't really need to wear a medical gown. You're actually not really in the area where you are going to actually go and get contaminated. So I think in the States and in Australia, we just wouldn't wear a medical gown. But in the UK, because it is very sort of traditional and they have a certain process, there are these particular medical gowns that they just wear because of reasons. They wear them because traditionally someone has worn a gown, even though there is relatively little benefit to actually wearing a gown from a bacteriological or virological level. So we looked at this and we thought this is a real opportunity to make a sustainable gown. Like, can we make a gown which is single-use personal protective equipment? Because this gown anyway, people are going to wear it. It's not really going to get dirty. It's not going to get covered with chemo materials, chemochemicals. It's not going to get covered with crazy amounts of bacteria. It's almost quite a superficial thing. So finding the right application and finding a gown where it was less likely to get contaminated, so it was easier to recycle. And then finding things like finding a cuff made from a similar material that is still soft, but you could still bond to the rest of the gown. Finding a collar that's comfortable to wear, but keeping everything mono-material, so it could be easily recycled. If you started putting things like glues, or you started putting things like Velcro, particular Velcros into recycling, it actually contaminates the whole lot. Some people, they cut the sleeves off so that you don't get contamination of a single material into the recycling process. So it was almost like going back to basics and contacting a whole bunch of different material engineers and people who could experiment with the material science and how to bond things together. So it hit this process where, from a completely sales point of view, people said, oh, we only want a recyclable medical gown if the whole thing is recyclable and we have a recycling process. But then it hits the point where if no one ever attempts to make a fully recyclable medical gown, how can we have a recyclable medical gown? If no one ever tries, we'll never have one. So we need to try something. So we've engaged on this process to create this medical gown where we can incorporate the zero waste process, but on those lower levels of protection that a single-use PPE medical gown could be fully recyclable. And that's in the right context. That's in a situation of reduced contamination and in simplified materials, and there are no crazy chemicals or contamination that's going. So people are still protected, but we are getting rid of the needless waste and setting a new precedent on how we could recycle these garments.
I think that's always a really interesting conversation because there is a lot within the medical industry that is single use. And that comes from the desire, for lack of a better word, I think in many cases, for it to be clean. And not feeling that many of our standard cleaning procedures would solve this component. Because to me, the immediate thing is, well, if you could work with a material for a low contact component that can be laundered, it can be worn many, many times. It's not just for, I might wear it only for one interaction with a patient, but then it can be washed. And I think that's not, because of the concern regarding cross-contamination and sharing, that's not typically what we're talking about in that space. In that, has there been any work with, I'm going to call them fiber scientists, but people who are really working in the kind of cutting edge space of, say, biomaterials, materials that are not polymeric or not synthetic polymer based, to make materials that their end of life would actually allot for them to have a smaller footprint?
I find that this area is really quite tricky because there's almost like what is intuitive to you as a designer. So, yeah, of course, if we could just keep on washing our materials, that would be great. And laundering, that makes perfect sense. But then when you go to speak to a bunch of medical experts and people who study viruses and contagion, all that kind of stuff, you very quickly realize that viruses and bacteria are so good at spreading that if you were to launder things, it's actually incredibly hard and extremely risky to follow traditional processes that we have in place. So in terms of if you were to, say, launder these things, you would need a very radical process that was extremely intense and probably need, like, it's not business as usual. You would need to do something quite revolutionary in that area, which is not impossible. It's just, it sets a precedent. Those facilities
Right.
need
It's
to
not
be
a
set
place
up.
where right now we have good material options in that
Yes.
space.
So what a lot of people were looking at was there are many advantages of using things which are single use in terms of like there is I think originally we had some of the design team look at historical records, and there were gowns that people would sort of reuse, but there have been sort of studies that have been applied to them, and it's almost like how much risk are these how much risk is a hospital willing to take on a certain process? And I'm not saying that these processes aren't impossible. It's just they require a little bit more thought in this area. We actually engaged with many of the material people we were engaging with were sort of material engineers, and they looked at ways of bonding materials in different ways. And we were able to keep things in a single material, so that kept things quite low tech in comparison to going super high tech and reinventing the wheel and that kind of process. But then the people who we engaged with, who were doing very cutting edge research, were the people who took the contaminated material and were able to take that material up to a high enough temperature to kill everything, and then turn that into a byproduct that they could recycle into something that could have a use after the life. So I would consider that an incremental step. Like ideally, I think you would love a thing that you could just wash everything off. But if you understand how antibiotic resistance works, how viruses constantly, if you wash them with one, what is this thing that you're washing with them? As soon as they get used to being washed in one thing, they develop an immunity to that thing, and then they come back and you bred that next super virus. So that's like, this is where like
Nobody
there's like
wants to
theory
hear
and
about that today. No super viruses today. I'm pretty sure everybody doesn't want to talk about that. But I think the single use and the recycling process of those materials is, I think, interesting in and of itself.
Yeah.
And I think, at least to me, what I'm hearing also is that we're making incremental improvements for today, and then looking towards, other incremental improvements moving forward that maybe involve things we haven't imagined yet. Is that a fair kind of summary? Whether it's a new material, a coating, a different assembly technique, or different manufacturing process?
We look at things which are incremental, but there's also the little things. So our CEO was very ambitious, and he had this idea that if we could make that zero waste saving, he just wanted a little stamp on the gown, and that was it was the carbon neutral stamp. So he wanted to do a carbon offset program. You wouldn't really normally do a carbon offset program, but the zero waste saving would give us what we needed to run the carbon offset program. So little savings here could translate to savings somewhere else. And the ability to shift things over just a little bit allowed us to start the conversation of where the research would be next. Even engaging, like we could run business as usual and you would make massive profits during a global pandemic. But this is the time where we have to sort of dig in and use, these medical companies did very well during the pandemic. They need to reinvest that money that they earned and prepare us for the next problems that are going to come up. And I think it's quite admirable that, what company has the ability to hire a zero-waste fashion designer to their bunch of medical experts and get them to optimize material? I think that's an incredibly forward-thinking decision and a great decision, like to get more creative people in a very sort of dry technical area is a very bold decision. And we need that. We need these incremental progressions, but we need them in order to get to those big leap forwards as well. And they're always working sort of simultaneously. It's like I take a leap forward with the zero waste garments, and then we need to pull it back a bit more so it's more wearable. But because we brought it so far ahead, even if we bring it back in a little bit, we're still making a massive saving and we're still doing a whole bunch of positive things.
All right. That is all really fascinating. And it's really interesting to think about something in a way maybe we hadn't in the past, but to realize the impact of both waste that comes from our medical industries and the need to be very conscious within a medical space regarding transmission and infection rates. I think this is something that's front of mind now for everybody in that space. So I think that's a really interesting component. I mean, you've touched on so many really interesting points. I have some notes here that are maybe, I'm going to go with scattered across the best, because there's so many exciting intersections and tangents and spaces that you've worked in that have really looked to change how we're considering fashion and design and materials selection, but more so even materials use in the end garment. One of my early notes I had actually put was more about zero waste patterning and how that now translates into a supply chain and the actual fiber selection, because so often when a designer actually gets the textile, it's been a lot of places before you had access to it. Is that a space that you've thought about or worked in, or not at this point?
Things are getting quite exciting in that area. You can only do one thing at a time, but for me, zero waste was kind of dormant for several years because I was figuring out the underlying mathematics of things. But in the last few years, it's come back with a vengeance. I'm going to go off on a slightly tangential story about how this kind of applies. So when Sir Isaac Newton was thinking about gravity, many people had thought about gravity, but what he needed was he invented calculus, like the thing that people find really difficult to track how things moved over time. And this was the key to things. So there are people like John Hooke who had thought about gravity, but without calculus, how could you actually make everything move? How could you actually get it to work? So when zero waste first came out, it was this beautiful idea, and I was brute forcing everything together, as you would, as many people, like stumbling around sort of figuring out gravity. But when I developed this geometry, this non-Euclidean curve pattern making process, that's almost like the calculus of zero waste pattern making. You needed this underlying mathematics to be that dexterous and skillful with your pattern making. So say you're going to cut something out, you cut one shape out, which has a curve, you get one side and it makes a very sort of a saddle shape, which is a hyperbolic shape. The other side comes out and it's a very spherical shape. So you know that if you've got one that's coming out spherical and one hyperbolic, you kind of have to balance them out. So you'll need to place certain curvatures in one place and certain curvatures in different places. But then you think, okay, are we just going to make a garment that requires less material? That's okay, it's nice, but can we do more? So imagine if you look at something like your fabric and it's got the grain on it. What if you turn everything 45 degrees, you get everything on the bias. So it's stretchy, and that's great. Everything is bias cut. It's sexier. It's smoother. what if we could make bias cut things using the same amount of material or less material and keep things zero waste? So there's an actual tangible advantage to making something zero waste. So a lot of things I've been playing with recently are basically taking the material, turning it 45 degrees and making things on the bias. So bias cut t-shirts, or I mean, more like dress shirts and things like that. Getting very specific areas, but because it's now bias cut, I don't need, it's more flexible. I don't need to follow the same pattern making rules if it was a more rigid material. From there, if it is so bias cut, can I use it to be an alternative to a stretch material? So there's loads of material science about how to recycle polyester or cotton or polycotton blended together, but the ability to make or recycle elastane or lycra is like, there's not much research in that area. So perhaps if we could create a garment that just stretches on the bias instead of using stretch material, that can actually circumvent a lot of problems. Or if we can look at how we would redesign the garment from scratch. So there are very traditional techniques that you would use in tailoring to get the back of your garment to attach together. But in things like activewear, they don't really use those rules because they have stretch materials, and also because they're not bound to the rules of tailoring. They just do whatever they want. They do what is most comfortable. So what happens when you're using tailored materials, but you're kind of stealing ideas from activewear and you have no traditions? You're just doing what works, what makes you happy, what seems to solve the function. Like, do I actually have to seal the ends of my sleeves? Can I just have them open and just cover them with something else? Like, there are ways that you can sort of get around traditional techniques and create openings in different ways. So it's almost like if you just throw out all the traditional rules and just use structure and function to guide what you want, how far can you push it? And I've had a lot of fun doing that at the moment with these sort of bias cut sort of zero waste t-shirts and dress shirts.
That's really interesting. I love hearing about that kind of differences in that design process. So I've actually invited some people from our virtual audience who had questions. So this is Professor Joy Sakar, who is a textile development and marketing professor, and also has worked on and helped collaborate with students on initiatives related to creation of more inclusive PPE that is also sustainable in its design process. So utilizing principles of zero waste design and also real consideration of the material selection. But I know he has a few questions, and so I wanted to invite him to ask a few of these follow-up questions as well. So Ajoy, the floor is yours.
Thank you, Mark. That was very, very interesting. Thank you. So my first question to you is just your opinion of where you think the zero waste design is progressing, especially in terms of scaling it up.
I think medical is a brilliant place to start because they're very limited. They're limited amount of sizes. In the research that we looked at, many people were comfortable wearing a very large size over. A smaller person would wear an extra large garment and wrap them around themselves. And there was almost like a perception that that was more protected. So there was an existing precedent to wear oversized garments over smaller people. When it came to the procurement of medical PPE as well, there was almost like a culture that accepted a limited size range. So that really helped. You need PPE to fit into an existing culture. You can't alienate the people who wear this as their armor every single day. So I think that will be important, but I believe over time the culture could change if we could show little differences. So I think things like if you could have a carbon neutral or carbon negative, just a little stamp or sticker on that, I think that would be a real badge of honor. There is a real concern from nurses that they are aware of the looming climate crisis and they would like to make a difference. I would personally like to see things like improvements in comfort, but it's an incredibly difficult thing to do when there's so many body shapes and sizes, and there are so many existing precedents in there. So I think what we're going to find is there's probably going to be even more collaboration between material scientists and designers. So when we have more control over the materials, we can do even more. So at the beginning, it's very much it's like we have an existing tool set, and how can we retool that to make things better? If we go deeper into the process of how are things recycled, it's almost like we can go from the very beginning of how the material is made all the way to the very end of what is the process that is going to recycle it, and have all the steps considered. And everyone from the design team to the CEO who will facilitate that will have some really important decisions and choices to make, which I think would deliver a better product, but a better design process.
And my other question to you is, for students who want to enter this field, the zero-waste design field, what would be your advice to them to proceed, not only in terms of courses, but also in terms of their mindset and skill sets? So what would they really like to have in terms of skills in order to enter this area?
All right, so I think I can approach that in sort of several different areas. So I've been for years, I've been working on a zero waste book, and part of that was to almost publish the non-Euclidean geometry pattern making techniques. That's kind of been delayed because I keep on just reinventing things and making it easier. So I was trying to do it as an academic text. When I now do it, I think I'm probably going to almost do it as a children's text or like a STEM text to make it really simple so that people can engage with the concepts themselves. I find ability to just there is a stigma against science and mathematics in the fashion field. In our university at UTS, I think the marks that some of the students need to get into the course, they have to be in the top 5% of the state. So very bright students, but as soon as they walk through those doors, suddenly like, oh my gosh, what's a square root? Like, math is hard. Like, there's a culture, like, people don't want to be seen as sort of savvy for that, and it's so silly. The engaging with the mathematics is an important thing. So just taking inspiration, instead of saying, oh, we're just going to be inspired by Salvador Dali's art, and we're going to be inspired by, you know, Coco Chanel and the same designers that everyone chooses, or we're going to make a collection inspired by the color red. You can go and find crazy mathematicians or who are doing amazing things, or an engineer who's busting out cool sculptures. So just crossing those bridges and being adventurous. The best way of crossing a bridge is to make a friend. Fashion designers are very good at making friends, tend to be very sociable people, even if they're very introverted. Like, I'm quite an introverted person. I can still make friends with a whole bunch of scientists because we can speak that common language. And sometimes you have to do the work yourself. So you have to educate yourself. Like, I picked up a lot of the mathematics because I was interested in it and I was curious. Fashion designers may not be interested in really obscure, boring mathematics, but they may be interested in the curvature of the universe as a theme. And then that may be what sparks them to go across and learn more mathematics, or be inspired by cool shapes that they see. So the ability to be comfortable with the STEM area and cross bridges is important. Zero waste is very particular because it requires a lot of failure, like loads of failure. In fact, when you make a garment, you're very much not going to make something zero waste most of the time. So embracing that failure is an important part of the process. If you're the kind of person who quits really quickly, it's just, you have to accept it as part of the process. The other thing that I can't overstate is pattern making. Sort of the ability to do a beautiful sort of watercolor sketch and then hand that off to someone to make into a pattern. The pattern maker is often the person who is overlooked because they have a slightly less glamorous part of the process, but it is the person who actually wills the shape into 3D existence. And there's a craft to it. and it is a difficult craft, but it is also, I find it to be one of the most fun things that you can possibly do. That is the designing, yeah, it is putting everything together. So pattern making used to sort of, there was, you know, you have illustration classes and people would illustrate a lot of the time. But what if you did the illustration and then you did a little doodle of what the flat pattern would look like? So most designers don't really do that. When I wanted to become good at zero waste, when you're in Paris, there's kind of a culture when you're in a cafe, all the seats face outwards. So you're people watching and people walk by and you watch them. What if you sort of sat there and you people watched, but you saw a person and you drew them, but you also drew the pattern of their garments? Imagine how you would very quickly get very good at drawing garments. Even if you didn't do it perfectly, you would get a sense of where the curves went. It would become really intuitive to you. And you would fail fast and you would fail quickly, but you would learn really fast. And I think these are the kind of things that you need. Those are like the simple exercises that you would need to basically get zero waste going. You just do those a lot of times and you get better. And at the beginning, you're terrible. But the secret of what a lot of I did was I did it for 2 years nonstop, every single day with consistency. And not many people are willing to put that time in. But if you say did pattern making a couple of hours every single day for 2 years in a particular field, you're going to get really good, no matter how bad you are. So you'll probably find out something about yourself as well. You might find, I really love a particular kind of curve, or I really love streetwear that is zero waste because it has more blocky shapes and I like those blocky shapes. Or you love high-end couture because it has the curves that you like working with. So I guess it's almost a combination of like science, failure, and pattern making, and practice. Put them together, zero waste.
Thank you. That was very well put. Thank you.
I was going to say, I heard a lot of really exciting things. What I heard here was a marketing plan for a curricular programming based at the university level that is interdisciplinary in nature, that gives students the opportunity to study science, design, mathematics, business, all at the same time, so they can work through some of these bigger challenges in partnership with their design work.
Like sometimes you want to tell people, oh, it's a secret sauce, or it's a special recipe, or it's this technique that I could teach you. But sometimes it's just practice. And sometimes it is hitting up the library, you know?
Sometimes it's a little like cooking. Sometimes it's a little research. Sometimes it's a little trial and error. Sometimes it's a lot of luck.
Or sometimes it's like call a friend, like call up your friend who was a quantum physicist and ask him some really vague questions and he'll give you some really interesting answers, you know?
I think it's to develop a fearlessness towards exploration in all of these areas and no fear that you can understand it in that space.
I think this is something I would probably focus on. So there's often a question of fearlessness in this area. And when people think about, so people who are like daredevils and they're really fearless and like they go to a situation and they don't feel the fear because they're missing the gene or the part of their brain that feels the fear. When it comes to this kind of design, you do feel the fear. You go there and you are uncertain and it is awkward and you don't know if it's going to be a result and you get nervous and you go through it. You can't go around it. If you bypass the fear, you're not really going to get that experience. You almost have to uncomfortably work your way through it. But as you've gone through fashion school, students go through very rigorous critiques and they develop quite a thick skin. So if they can put up with a Devil Wears Prada style critique, I'm sure you can deal with going to the library or asking awkward questions to a scientist or drawing a whole bunch of more sketches because the first few ones didn't work out.
I love it. This conversation has been really just so inspiring to think about how exciting it is to work at the intersection points in the power of interdisciplinary collaborations, and also, asking your friends who haven't studied the same things as you or have different perspectives. I think that is so exciting. So I am so thankful for you sharing your story, talking to us about how you made all of these different transitions, but also really married a true STEAM, science, technology, engineering, arts, and mathematics background together for yourself. You really kind of knit that in both your studies. And I think that's a really unique place and opportunity that many of us have not had. And I am still just fascinated, and I hope personally that you do so much more work relating to your, I'm going to call it problem-based learning, but where you are teaching calculus and design principles to students, especially these students who maybe aren't just at the university level, but much younger than that. I think they will really help us find solutions going forward. And I think these skills in sciences and in math, partnered with amazing talents in art, will really fuel us a rich future that allows for great design, great problem solving, and really innovative solutions in this. So in that space, I thank you so much for coming and being one of our highlight Changemakers for this year's sustainability conference. It has been such a pleasure to hear your work you've done, to hear your story. I see many points where we can come back and have further discussions. So again, I want to thank you on behalf of FIT and FIT Sustainability Council and the FIT Foundation for your contributions and work in the zero waste space, and also for really being an innovative, interdisciplinary or transdisciplinary leader for the fashion industry. So thank you.